What I like about it is it's a wonderful blend of local, small town, family oriented with cutting edge technology. Here on Schoolhouse Lane, I was amazed when I first walked into the building and saw the level of technology and the level of development that's going on right in this building. So really a neat combination of both. For someone who loves the community, has family, children, very vested in the community, yet I'm an engineer. I like to sell, I like high tech, so it blends all of that very nicely.
We have a very dedicated group of employees, most of whom have been with us for many, many years, and this is part of their life. I mean, they really believe in the company, they believe in our mission as a company, and I think that's largely a result of the success that we've had as a company.
And then I came here to IMS in 1981, and I've been here ever since, and I do like it here. I could retire, but I don't want to just yet, because I like the people here. It's a great place to work. It's close to home. Nobody bothers you. There's no stress. There's no pressure. People are nice, so it's really a good place to work.
Well, IMS, which stands for International Manufacturing Services, was incorporated, or basically we were born, in 1974. We were created by a gentleman named Hank Leave and his wife Tina Leave. They're both of Estonian descent. And Hank, who was a brilliant engineer, eventually, after he served in the service and got his education, founded International Manufacturing Services. But in between that time, he was a top-notch GE executive, ran a huge General Electric plant in France. Then he decided he wanted to have his own place, his own business. And that's how International Manufacturing Services became an entity unto itself. The company got its start in the watch industry. At one time, believe it or not, every Timex and Bolivar and Pulsar watch had 2 IMS resistors in it. And why our technology caught on and was superior to our competitors is because we used the lasers, which were so much faster than the sandblasters and the other techniques. They're in every kind of component or any kind of module that you can think of, from the cell phone to a Tonka toy that's electronic, has a resistor, and ours are in quite a few of them. So IMS evolved from a little idea born in the mind of a very, very intelligent man into what we are today. Later, we purchased a couple more acres of land. We now have 3 acres and did a couple of expansions, one in '98 and the other one in 2000. And now we have 12,000 square feet on 3 acres. Sitting here in this beautiful little Portsmouth, Rhode Island, is this manufacturing plant producing high-tech components that are sold all over the world, that are helping us with homeland security and defense. And nobody even knows that we're here because we try to keep a nice low profile and keep ourselves environmentally sound and nice and quiet. Our friend Inigo Loyola here is one of our manufacturing engineers, and he will digitally construct any custom component that we have to make for our customer using AutoCAD programs and other drawing tools. So we can precisely make anything custom that a customer may want, a different size, a different configuration, a different set of layers, and they're all created here before we go in to build our tooling. The technician selects the appropriate substrate or base material for the product that will be manufactured. IMS typically uses alumina, which is aluminum oxide, or aluminum nitride. These are ceramic plates that we use to build our components. Once the substrate is aligned, a masking tool called a screen is placed over the plate, and a wiper tool called a squeegee pushes the electronic film into the tool. This paste material is often loaded with conductive metals like gold or silver, and they're suspended in a gel-like material state, similar to the consistency of smooth peanut butter. The consistency of the material is important to be able to print very precise design. After the plates are printed and dried, they are sent through a sintering furnace at temperatures approaching 1600 degrees Fahrenheit. This exposure to heat allows the non-metallic or glass elements of the paste to escape. In these belt furnaces, there are 4 or 5 zones of heat temperature that go all the way up to 850 degrees Celsius. As the belt moves through the furnace, there's a cool-out zone. And as the parts come out of the end of the furnace, they're already cooled to the touch. In some products, many layers of films are applied on top of each other to build up a completed component, perhaps 2 terminations, a band of resistor material, and then finally a passivation glass coating. Once a plate of components is completed, it may require tuning. Values can be tuned using a probe and laser machine. The process is commonly known as laser trimming. In this machine, resistance values are measured, and the laser beam cuts away small amounts of material to restrict the current flow. The action raises the value of the component to the desired value that the order requires. If the laser machine finds a component that cannot be turned into the correct value, it'll mark that component to be removed at a later step. After the plate has been tuned, the final process is to singularize them into individual pieces. This is performed by a robotic saw that will cut the plates using diamond-infused saw blades. That blade he has in his hand is 8/1000ths of an inch thick. In order to hold the parts in an array during this process, they're mounted to a wax glue and onto a glass plate before they're cut. Diced plates are then inspected on a hot plate where the wax that holds each component is softened so that it may be removed by a technician. Each part is inspected for workmanship and trim quality. The inspector will also remove any parts that could not be trimmed to value and were identified by the laser in the trimming step at this time. After the inspection, all of the good parts are consolidated together and put into a beaker of isopropyl alcohol or rubbing alcohol, and then they're put into an ultrasonic cleaner to be cleaned. So all the parts that may be clumped together because of the waxy substance now can all be flushed apart, and they're perfectly cleaned, so when the customer sees them, there is no wax residue. After being cleaned, these components are ready for final inspection. In some cases, the parts are 100% value and visually inspected. After passing inspection, the parts are ready for customers who require loose or bulk-packed components. Many customers need parts prepared for use in automatic handling systems. In most cases, this requires that each component is placed in a tape pocket, commonly known as tape and reel packaging. Each component is inspected, oriented, and installed in its own tape cell, and then sealed by a thin layer of plastic film called a cover tape. After the final quality check, this part is ready to be shipped to a customer anywhere in the world for uses in electronic devices ranging from radios, satellites, sensors, MRI equipment, meters, pacemakers, and a whole host of consumer devices that we handle in our own daily lives.